Good day, ladies and gents. We are on Unit 10 review for the EOC review. We're doing pages 28 through 31. Make sure you guys have out your Unit 10 hot topics. That will definitely help. If you need to take a picture of this right here, that would be a very good thing to do. So if you need to, pause now, take a picture of that, copy that down on your hot topics if you don't already have a copy of that. Excellent. All right, so let's get this going. So we're opening it to page 28. All right, so on page 28, in the circle shown below, the measure of arc. So that's the arc, PR. So from P to R, and we're doing the arc. That means the curve on the outside. That is 120 degrees. And angle, RPQ. So the center angle is P. So angle P. So no confusion as to what angle we're talking about. So it's just this angle right here is 40 degrees. So we put 40 degrees right there. What is the measure of arc PQ? So we're talking about the outside, so we're looking for this, and let's call that X. All right, so let's think about this for a second. If the angle at the back of the movie theater, if the angle at the back of the movie theater is 50, then the movie screen would be 100 because the back of the, so if it's at the center, it would be the same. Center means same, right? So if that's 40 degrees, this would be 40 degrees. If your projector's at the back of the movie theater, it doubles on the way out to the movie screen will get twice as big. So if this is 40 degrees, then this right here, that it projects, so you take this these two sides right there, and it would project this right here. That would be your movie screen, and that would be 80. And then all the way around in a circle, so all the way around in a circle adds up to 360. So what we have is 120 plus 80 plus x equals 360. So that would be 200 plus x equals 360, just showing more work, and x would have to be 160 degrees. Awesome. And so that would be your answer right there. So pretty simple, right? I'm just showing more work than I need to, just to give you a nice idea how to do this. All right, number 2. Given the circle O, what is the measure of arc? So we're looking for the arc, not an angle. Arc, ADB. So ADB, this is the arc. So I know a bunch of you guys are like, oh, this would have to be 85. But that's not what they're looking for. So I'm going to zoom in. They're looking for all of this. So that would be your x. And what would that have to be? Well, we know that all the way around in a circle adds up to 360, right? So x plus 85 equals 360. What would x have to be? You guys can figure that one out. So that's pretty easy. All right. And then number 3. Okay. Kayla inscribed a kite. So here's a kite as shown below. If arc ADC. So I'm going to start writing in blue or in pen what they're going to give to us, and then all my work will be in red pen. So that will help us out here. They said arc ADC. So ADC. So all of this is 205. So what would be the angle? So they want the angle this time of ADC. So angle D, right? So where's D? So they're looking for this. So we're looking for that right there. Okay, so there's a couple of different ways how to do this. So here is way number 1. So option 1. Okay, the first thing is X projects all of this, right? So if I can find this arc, then I would be able to bring it back on the inside. So one way is I know from here to here is 205, right? And so what would be this part right here in order to complete the 180 degrees? Complete the 360, right? So all this has to add up to 360. So if it adds up to 360, subtract the 205, this angle right here would have to be 155, right? Okay, so then the next step would be, okay, if this is 155, now I should be able to find angle X. So you see how, okay, so if this is 155, what would this angle back here be? You would just have to divide by 2, and that will be your answer, right? Okay, so I'll let you finish that one. So the second option, how to look at this, option 2, because there are multiple ways how to do this. Another way to look at this is this. Okay, so we have from here to here is 205, right? So, and that was projected by angle B. So if this is 205, all of this, what would angle B have to be? You would divide by 2. So 205 divided by 2, this angle right here would have to be 102.5. Okay, so then with that, the second step would be if this right here is 102.5, I know that this angle and this angle right here adds up to 180 degrees. So 102.5 plus that x is equal to 180 degrees. And how did I know that? Because of this. For an inscribed quadrilateral, the opposite angles right here, the corners, the opposite angles would add up to 180 degrees. So A and C add up to 180 and B and D add up to 180. So, and you're going to get the same answer on both of those. So I just gave you both of those options. Good to know both ways. And you just have to finish both of them. So I got you almost there. I was just showing you different ways how to do this. Awesome. All right, number 4. All right, so number 4, QS is the diameter, right? So QS, so that's the diameter. That means I cut that sucker in half. And also this is perpendicular, right? Okay, if the arc of PQR, so arc PQR, so all of this right here is 130. All that's 130. What is arc PS? So they only want from here to here. Okay, the easiest way to do this, okay, do you agree that this got, this right here got cut in half? So if this is 130, divide that by 2, this angle right here would be 65 and 65, right? And so 2 ways how to do this. One is, well, I know that from here to here makes 180 degrees. So if this is 65, what would be left over? The other way to do this is, well, if this is x, this will also be x. And I know that 65, 65, x, and x add up to 360 degrees. And so that's another way how to do that. And all you have to do is choose your answer. So I got you most of the way there. Sweet. All right, number 5. All right, so on number 5, here we go. Okay, the minute hand of the clock points at 12. And the hour points at 8. What is the measure of the smallest arc? So they want from here to here, right? So how much is it from each little part? So all the way around in a circle is 360 degrees, and it was broken up into 12 parts. So 360 divided by 12, and we get that each of these is 30 degrees. Now this is the important part. You need to write 30 in here. I know you guys want to go, oh, that's 1, 2, 3, 4, 5. Don't do that. It's how many hops, right? Not the dots. Count the hops, not the dots. Be the bunny. So this is 30, 30. All these little parts are 30 degrees. So the distance, the little arc from here to here is 30 degrees on all these. So this is 30, 30, 30, 30. So how many 30s were from here to here? That's 1, 2, 3, 4 hops. So that's 4 hops. So how many degrees is that total? Add those together, and that would be your answer. And it's your job to finish that up. All right, sweet. So that was page 28. All right, let's go ahead and keep going. Let's go ahead and go to page 29. So we're going to page 29. Okay, so on page 29, given the figure below, and AB is the tangent, okay, what is angle ABC? So we're looking for the angle. So we're basically looking for angle B, which is right here. Right, so where is the angle? The angle is on the outside of the circle. So if you look at your hot topics, so if the angle is on the inside, you would add up the arcs, divide by 2. But if you're on the angle is on the outside, you would subtract them and divide by 2. So in our case, it looks, let's see, tangent, so it looks like this one right here. So you have to look at what it projected. So if I do this, I only care about those two arcs, this arc and this arc. So this other smidgen right here, that extra little piece, I don't care about. I might need it in order to get the rest of the circle, but that's about it. All right, so let's do this. So what I really want is this arc, because that's, so it projected that arc and it projected this arc. So I want the red and the blue. So I have the red, but I'm missing the blue. So I need to go find that blue one, right? So to find that blue one, I know all the way around in the circle, and just so you can help, so I can help you focus here. So this from here to here is 65. From here to here is 125, and I'm missing this part. So all the way around is supposed to be 360 degrees. So we need to find that missing part. So 360 versus subtract the 65 and the 125 that we already have. So this right here would have to be 170, right? So this arc right here, the blue arc, is 170. Now that we have the two arcs, now we can plug it into this equation where it is the big arc minus the little arc and then divide by 2. So the big arc, so our angle, which is x in this case, is equal to the big arc, 170, minus the little arc, 65, all that divided by 2. So do the top first, equals, then divide by 2, and that will give you your answer. So that's your job to finish that one off. All right, and then number 2. Given RB is a tangent, so this is a tangent line to circle A at point B, and BD is a diameter. So that means I cut that sucker in half. So all this is 180 and all this is 180 degrees. Okay, what is the angle B, right? Now B, I don't know if I'm talking about the top, that middle, the left side, or a combination of those. So let's see. So it's CB R. So we're looking for this from here to here. That's our X. All right, so I'm going to zoom in. So they said CBR, right? So we're looking for CBR. So we're only looking from here to here. CBR, right there. We're only looking for that. Now that projected this arc right here. So if I can find that arc, I can find that angle. So if this right here was 70 degrees, I know that half of the circle is 180 degrees, right? So if this is 70, this would right here have to be 110. So if the arc, so if this is 110, what would be the angle right here? So that's still on the corner of the, in the back of the movie theater, right? So it looks like this, more looks like that. So if this is 100, that'd be 50. So we divide by 2. So take that, divide by 2, and that will be your answer. So it's your job to finish that off. Okay, number 3. Number 3, in the circle below, A, B, and CD are chords intersecting at E. Awesome. And it's not at the center. The center is right about here. And so this is not the center. Arc AC. So from A to C is 30 degrees. And arc B to D, here is B, here's D, is 70 degrees. And they want angle E. Now, E, I don't know if I'm talking about the top, the bottom, the left, or the right, or a combination of those. So let's see. They said AEC. So AEC is this. So this is X. Now, what did that project? So I know this arc and this arc was projected by here and here. Okay, awesome. So for this, I can find that missing angle right there, and these arcs were projected by these angles right here. Be careful. Sometimes I'll be looking for this angle over here. You would have to find this one first, and then you can find that. But in this case, it's really simple. So we can just find these two angles right here, and because it's on the inside, we're happy, right? Because the angle's on the inside. So the angle in this case is X is equal to the two arcs projected divided by 2. And that will give you those angles. So let's say it's not, but let's say that it was like 80 degrees. If it was 80 degrees, then this angle over here would be 100, just putting that out there. Okay, and it's your job to finish that up. Sweet. All right. And then number 4. All right, on number 4, AB. So AB and BC are tangent lines, and they said that arc AC is 130. So this is 130 degrees, so 130. What is angle B? So this is X. All right, so now that one, so the angle's on the outside, so and it projected this this angle here. So it projected the red, and it also projected the other part, which is all this blue. So, and actually together, those two arcs complete 360 degrees. So I can find the blue by subtracting 360 and 130. So what would be left over? So I know that that blue arc and this red arc make 360 degrees. So 360 subtract the 130, and I would be left with that this is 230. Okay, now that I have that, now just like how I said right here, now I could actually plug it into this equation where the angle is equal to those two arcs subtracted, divided by 2, and it's your job to finish that one off. All right, pretty simple. Okay, and then number 5. Number 5. All right, they want angle PTS. PTS. So that'd be this angle right here. This is X. However, now here's where I'm a tricky little bugger. All right, however, see these two arcs right here? This arc and this arc are projected by this and this. So we have to find that first. So we have to find this angle first. So that dot is equal to those two angles added together and divided by 2. And now why are we adding them versus subtracting them? Because they're inside the circle, so we're happy, right? So add those two together. So 186, add the 112, divide by 2, and we would have that that dot is equal to 149. And usually you would be done. However, we're not actually looking for that angle. We're looking for X. So I know that these two add up to 180 degrees because see how they make a straight line together? So in order to finish that off, I know that X plus 149 is equal to 180, and you guys can finish that off and write down that answer. Sweet. So that was number 5. All right, let's keep going. So we have done page 28 and 29 so far. All right, we're going to go ahead and move on to page 30. All right, so on page 30, a company is designing a glass table for Mr. G's house. Part of the circular stained glass table will be a different design than the rest. How much of the stained glass table will be different? Use that. So basically, it's a table. What are we looking for? We're looking for the sector area, right? All right, so radius, diameter, and then what was the angle? So that's theta, the angle, right? Okay, so we have r is 6, that's the radius, from the center to the edge. So then the diameter would have to be 12. Now at this second, our theta is 3 pi over 4, but we're not allowed to have a radian. So we have to change this into degrees. So radians to degrees. We want 180 degrees, we want to get rid of the pi. So we're going to multiply by 180, divide by pi. Multiply straight across. So 3 times 180 pi. So treat the pi like it's an x. That'd be like 3x times 180. So that'd be 540 pi all over 4 pi. The pi's cross out. 540 divided by 4, and we get that theta would equal 135 degrees. Awesome. All right, so that is our angle. Now that you have that, you can put it into the sector area. So sector area is equal to a percentage of the area. That is the angle over 360 times pi r squared. So it's percentage over the area. So the angle is 135 over 360 pi 6 squared. And all you have to do now is type that into the calculator and round to the nearest tenth, and it's your job to finish that off. Sweet. All right. Number 2, given that the radius of a circle, so radius is 16, so thus the diameter would have to be 32, and theta is 3 pi over 4. So we have to change that into degrees before we can start this, right? So multiply by 180, divide by pi, multiply straight across. This should actually look super familiar because we just did it. So that's 540 pi all over 4 pi, and we get 135. So that is our angle. And what do they want? They want the length of the arc. They want the length of the arc. So that is, so arc length, that is a percentage of the circumference. So that is the angle over 360 d pi. So that would be 135 over 360. Your diameter is 32 times pi. And all you have to do now is just type that into the calculator. And they said, did they say anything about rounding? They did not say anything about rounding. So just write down the answer, whatever you get. Now, if you get 0.333 to 333 and they did not say anything about rounding, then something's wrong. So you should have a terminating decimal somewhere. It might be 3 digits, it might be 5 digits. You give me that. Awesome. All right, so you guys are in charge of number 2, finishing that off. All right, number 3. Given the circle below has a circumference, so they gave us a circumference, is 144. What is the arc length? Okay, so the arc length equals the percentage of the circumference. So that is the angle. The angle is 70 degrees over 360, and the circumference, they gave you the circumference. We're not typing in d pi. They actually gave it to us. So that would be 144. That's what you guys have to do. And all you have to do now is type that into the calculator and figure out which one of those is the correct answer. So it's your job just to finish that off. Awesome. Okay, number 4. All right, so on number 4, we have the area of the sector with a central angle of this. So that's our angle. And they said that the sector area is this. And they want you to find the length of the diameter. All right, so the sector area equals the percentage of the area. Now they gave you the sector, which was 38. The percentage would be the angle over 360. So the angle's 30 over 360, and the area, they didn't give it to us, so it's just pi r squared. So we're going to solve for this. So this is a good problem to have. So this right here, this is technically a number. 30 over 360 and pi, those are numbers. So let's go ahead and just multiply those. So 30 divided by 360, multiply by 3.14. So 30 divided by 360 times 3.14. Okay, we have 38 equals, and we got 0.261666666666667 r squared. So this circle turned into this circle. That's what's happening. Okay, now how do you get r squared by itself? So then your next step, so 38 equals that big long decimal, r squared. We're going to divide by 0.2 on both sides. I ran out of room, so I'll just keep going down here. So 38 divided by 0.261666666, the more the merrier, right? 7. All right, equals. And we get this answer. So we have, I ran out of room, so I'll keep going. 145.2229299 is equal to r squared. Okay, now what do you do next? I'm going to write this over again. We want to get r by itself, so we're going to square root both sides. 29, I dropped 1, here we go, and then 299 equals r squared. We're going to square root both sides. All right, so the square root of 145.2229229, we get 12.05084739 is equal to r. Excellent. So now we have r. Now what did they want? They wanted the diameter. So what are we going to do? We're going to multiply by 2. So multiply by 2 in the diameter. So with this big long decimal times 2, and we get 24.1016 blah 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 blah. So what would be the better answer? That one right there. Okay, that was one way how to do this. That was one way. The other way was they gave you multiple choice, right? So here's another way. So this is option 2, and this might be better for you. Option 2 is change these into radius. So if this is the diameter, so if the diameter is 7, then the radius would have to be 3.5, right? And just plug it into the equation. See if it pops out as 38. So that would be 30 over 360 pi 3.5 squared. If it pops out as 38, you know that you're correct. So let's see. So 30 divided by 360 times 3.14 times 3.5 squared. And I get 3.2. Is that 38? Nah, that doesn't work. So this is me just typing stuff in, right? So the question is, do these equal 28? Does it equal 38? That's the question. Does it equal 38? So if I have 7, then the diameter, the radius would have been 3.5 or 7 or 12 or 24. So if that was the diameter, so all I'm doing is plugging in these magical numbers and see if it works. This didn't work. All right, so if I type in 7, so if I do 7 squared, does that work? I get 12.8. So that's not 38, right? We're seeing if it pops out as 38, so that didn't work. All right, what if I type in 12 squared? That works out. And what if I typed in 24 squared? That didn't work out. So both ways, I was able to get the same answer. So you do what works for you. So I basically did that one for you, and I showed you both different ways how to do this. Excellent. And then, okay, then number 5, if the circle B has a radius of 8, so that means the diameter is 16, and the central angle is 110, what is the length in feet of the arc A to C? Okay, so pretty simple. We want the arc, right? So that would be, and I ran out of room, so I'll put it down here. So they want the arc length. So that's percentage of the circumference. So all you have to do is the angle over 360, d pi. It's your job just to take that information, plug it in there, and you guys can finish that one off. Awesome. All right, let's do one more page, guys. All right, page 31. I love this one. This is good times. The center of a circular flower has a diameter of this. So if the diameter, so radius and diameter, right? So if the diameter is 4, what's the radius? That would be 2. And they said that the center, that will be your H and your K, right? Okay, so with that information, x minus h squared plus y minus k squared equals r squared. Now you see these minus signs? So when you plug in your HK, it's going to feel like it flips. It's going to feel like it flips. So that would be x minus a negative 2 squared plus y minus your positive 1 squared is equal to your radius, which is 2 squared. All right, now you have to clean these up. So if you see like an x minus 0, the minus 0 is not doing anything, so just drop it. And now the parentheses aren't doing anything, so drop it. If you have a minus and negative, that's really a plus sign. If you have like 5 squared, actually finish it off squared it. If you have a square root squared, the square root and the square cross out, and you're just left with the number. So those are all the ways to clean that up. So in this case, it's x plus 2 squared plus y minus 1 squared. And what's 2 squared? 4. So you just pick out which one's your answer. All right, and then number 2, determine if the equation whose center, so that center means HK, and this is the point, so that's my XY. The thing that you're missing on this is your radius. So there's multiple ways how to do this, but I would rather just keep using this way. If it ain't broke, don't fix it. So we have x minus h squared plus y minus k squared equals r squared. Plug in what you know. We know hk, x, and y. We're going to solve for r. So I'll zoom in here. So we have your x was a 4 minus your h, which was a negative 10. And notice I'm not cleaning this up. I'm just typing it in straight up. Plus your y, which is negative 2, minus your k, which was a negative 4. All that squared is equal to r squared. So we're going to take this and we're going to type this in the calculator. So we have 4 minus a negative 10, and we get a positive 14. And then we get negative 2 minus a negative 4. That is a positive 2 squared is equal to r squared. And when you square these, you're always going to be positive. So if that was a negative 14, or let's do this one. If this was a negative 2, when I square it, it's going to be a positive 4 no matter what. So 14 squared, you get 196. 2 squared, that is a 4. And you get 200 is equal to r squared. Now you could go the extra step and find r, but why bother? Because you're going to write down the equation anyway. So I would just stop right here. So stop right there, and then we go x minus h squared plus y minus k squared equals r squared, where you're plugging in your h, your k, and in this case, instead of just r, you're going to plug in r squared. So that'd be x minus negative 10, all that's squared, plus y minus your negative 4, all that's squared, equals, and what was your r squared? Just the number 200. So not 200 squared, just 200. And it's your job to clean that up. So you're almost done with that one. All right. Okay, number 3. And remember, you have examples of this on your Hot Topics. So in this case, we already had our center, so we just jumped straight to this and this. So if you need to take a picture of that, go ahead and do that now. But I think you already did. Okay, and in this case, we're going to be doing general to standard. So you have to make sure that all the variables are on one side and all the numbers on the other, all the constants. Okay, so here we go. So we have our x's on the left and our numbers on the right. So we have x squared, leave some space, plus y squared plus 6y, leave some space, is equal to 7. Okay, so then you're going to take whatever your b is. In this case, we don't have one. So that'd just be 0 over 2 squared, which equals 0 squared, which equals 0. That's our first bubble thought. Over here, you take a positive 6 over 2 squared, so you divide that by 2, equals 3 squared, which is equal to 9. That's your second bubble thought. Your third bubble thought, whatever your whole numbers you got at the end, just add that to here. So we're adding 0, we're adding 9. So those are your 3 bubble thoughts. Okay, so then whatever you got here, put your x plus in front of it. So it's x plus 0 squared plus, and then we have y plus 3 squared is equal to 16. Okay, and remember, whatever sign you have here, it's going to have the same sign. See how that's a positive 6? That's a positive. This will also be positive. So we're not flipping anything, not yet. Okay, clean this up. See that plus 0, it's not doing anything, so drop it. And the parentheses aren't doing anything, so it's just going to be x squared plus y plus 3 squared equals 16. All right, so that's our equation. So there's our equation, but they also want the center and the radius. All right, so now let's actually pull things out. Okay, so our center, when you pull this out, there's nothing here, so that's a 0. When you pull this out, that will flip, that's a negative 3. And over here, for your radius, what I like to do is always set that equal. So right here, we have 16 is equal to r squared, right? Because r squared, that's really r squared. So I'm gonna zoom in just in case. All right, so write this over again. We're gonna square root both sides, and 4 is equal to r. So my radius is equal to r, is equal to 4. And be careful, if they wanted the diameter, that would have been 8. Sweet. Okay, moving on up. All right, now number 4. Write the following equation. So we just did this. So before we start, though, we have to space this out. We have the negative 2 on the wrong side, so we're going to add 2 to both sides. Okay, so we have x squared plus 8x, leave some space, plus your y squared plus 12y, leave some space, is equal to that positive 2. And you just do everything that we just did a second ago, but I at least started you off. Okay, and finally, number 5. All right, so just in case anyone's still copying. So number 5, which graph represents this? Okay, so all we have to do is pull out our HK and our R, and then we'll be able to solve this. All right, so I'm going to zoom in. All right, so when you pull out your HK, what would it be? And pull out your R. Um, and then with this information, you should be able to pick out which picture it is. And that's it. All right. So hopefully that helped you guys out. I hope you are super prepared for next week's quizzes and all that stuff. Have a great and wonderful day.